Can you imagine being able to choose what your future child will be like? From eye color to resistance to genetic diseases, and even physical or intellectual abilities. Sounds like something out of a sci-fi movie, right? But in the real world, designer babies are closer than we think. And while this seems like an incredible advancement, it also raises some eyebrow-raising questions. Are we crossing a dangerous line? Is this the beginning of a new era of genetically modified humans? Today, in Lumina, we'll dive into this fascinating and controversial topic. To understand where this conversation about genetically modified babies begins, we have to go back to 2018, when Chinese scientist He Jiankui shocked the world with a jaw-dropping announcement. The first pair of human twins had been born with their genes edited in a lab before birth. Jiankui's secret weapon was a tool called CRISPR-Cas9, but before we continue, let's break down what it is and how it works, because although it sounds like sci-fi, it's very real. CRISPR-Cas9 is a genetic editing technology that works like molecular scissors. But not just any scissors, they're the most precise scissors you can imagine. This tool has two main parts. The first is CRISPR, which acts like a genetic GPS. It's an RNA sequence that knows exactly where to go in the DNA, like giving it the exact coordinates on a map. The second part is Cas9, a protein that works like the scissors. Once CRISPR finds the right spot, Cas9 cuts the DNA right there. Why cut the DNA? Imagine DNA as a set of instructions for the human body. If there's a typo in the instructions, a genetic mutation, CRISPR-Cas9 can locate the error, cut it out, and in some cases, replace it with the correct version. In Jiankui's case, he edited a gene called CCR5, which acts like a door through which HIV enters cells. By disabling this door, the girls were born with supposed immunity to HIV. Sounds great in theory, right? But the reality is a bit more complicated. First, CRISPR-Cas9 isn't perfect. While it's extremely precise, it can sometimes cut in the wrong places, causing what's called off-target effects. It's like trying to fix a typo on page 100 of a book and accidentally tearing a page from the final chapter. The result could be disastrous, causing unexpected mutations or even severe health issues. And second, Jiankui didn't thoroughly test whether disabling CCR5 could have side effects. Later studies suggest this gene could be linked to the body's response to other infections or even vital brain functions. But let's get back to the story. Jiankui carried out these experiments in secret, without following ethical or legal standards. He deceived the parents of the girls, making them believe it was a safe treatment, and didn't consult or get approval from the relevant institutions. Basically, he acted like a rogue scientist in a movie, but without the happy ending. The scandal exploded quickly. Jiankui was sentenced to 3 years in prison and fined millions of yuan. In 2022, he was released, but he left behind a legacy full of tough questions. Was he a reckless man who put human lives at risk, or a visionary simply ahead of his time? Maybe both. One thing's for sure, this case marked a turning point in the history of genetic engineering. CRISPR-Cas9 has immense potential, not only to prevent genetic diseases, but to improve our quality of life. Imagine a future where we could eliminate mutations that cause diseases like cancer or design personalized treatments for each person. Today, that sounds crazy. But decades ago, things like vaccines or organ transplants sounded just as wild. The Chinese Frankenstein case raises a key question. Are we ready to use this technology? Because science doesn't stop, and what today seems like science fiction could be the norm tomorrow. The truth is, genetic engineering is on the rise, with a promising future in the world of medicine. Remember, genetic engineering is essentially the ability to rewrite DNA, that instruction manual that defines how our body works. In this field, CRISPR-Cas9 has been a game changer. As I've told you before, CRISPR acts like a molecular GPS that can find specific addresses in our DNA, and Cas9 is like precision scissors that cut exactly where needed. Once the DNA is cut, scientists can remove, repair, or even replace parts of this manual, correcting mistakes or introducing improvements. This level of precision opens up a world of possibilities. For example, we could fix mutations that cause hereditary diseases like cystic fibrosis or sickle cell anemia. We could also modify genes linked to a higher risk of cancer, reducing that vulnerability before it manifests. In short, CRISPR-Cas9 lets us dream of a future where we prevent diseases instead of just treating them. Imagine adding to that list a disease that kills millions of people every year: cancer. To understand cancer, we first need to remember that our body has an incredibly sophisticated immune system designed to detect and destroy any threat, including defective cells. When a cell makes an error in its DNA and starts behaving abnormally, it has a safety mechanism called apoptosis. It's like the cell says, "Something's wrong with me. I better get rid of myself before I cause problems." This usually prevents defective cells from reproducing. However, some defective cells manage to dodge this self-destruct mechanism and start multiplying uncontrollably. This uncontrolled growth is what we know as cancer. This is where natural killer NK cells come in. They act like security patrols for the immune system. These cells are designed to detect and destroy abnormal cells before they become a bigger problem. But cancer has a trick up its sleeve. It's an expert at camouflage. Cancer cells can hide from NK cells, fooling them into thinking everything is fine. And when defective cells manage to evade both self-destruction and NK cells, they start forming tumors and spreading throughout the body. This is where genetic engineering comes in. Scientists are working on ways to reprogram NK cells to make them smarter and more effective. Imagine we could train these patrols to spot even the best hidden cancer cells, turning the immune system into an unstoppable force against cancer. We could also design personalized gene therapies that strengthen these defense cells, giving your body the tools to wipe out any tumor before it causes harm. Now, back to Chinese scientist He Jiankui. Yes, the same one who announced he had created the first genetically modified girls using CRISPR-Cas9. His goal was to disable a gene called CCR5, which acts as a gateway for the HIV virus into our cells. By eliminating this door, Jiankui wanted to make the girls immune to HIV, but the reality wasn't that simple. Although CRISPR-Cas9 is a powerful tool, it's not perfect. It can cause unintended cuts in other parts of the DNA, known as off-target effects. These errors could cause unexpected mutations or even serious health problems. Moreover, Jiankui conducted these experiments without adhering to ethical standards or obtaining the necessary approvals. This sparked a global backlash that led to his imprisonment. Jiankui's case raises an essential question. Are we ready to use genetic engineering on humans? Although his experiment was reckless, it also opened the door for important discussions about how this technology could transform our lives. Today, we already have techniques like pre-implantation genetic diagnosis, which allows us to select embryos free of genetic diseases. For example, it's used to prevent Down syndrome. But in the future, we might go even further. Not just eliminating diseases, but designing healthier, longer-living babies who are resistant to conditions like cancer or neurodegenerative diseases. Some scientists believe that in less than 20 years, we could see the birth of the first genetically modified babies designed specifically to have enhanced abilities. Can you imagine a world where genetic diseases are a thing of the past? This future is possible, but it also raises ethical questions we'll need to address carefully. Genetic engineering is an incredibly powerful tool, capable of revolutionizing medicine, improving our quality of life, and extending our longevity. But it's also a technology that must be handled responsibly. Are we ready to take on the power of redesigning human life? Where do we draw the line between preventing diseases and playing God? Let me know your thoughts in the comments, and don't forget to subscribe to Lumina, where we explore how science and technology are shaping tomorrow's world. See you in the next video.